Welcome back. In this video, we are going to learn one of the most powerful ideas in all of programming, functions, and the concept of modular programming that comes with them. Once you understand this, you will start writing code that's cleaner, shorter, and so much easier to manage. So here's the concept that we will cover through the video, all centered around one core idea: breaking your code into small, reusable, well organized pieces. We will start with what a function actually is, move into parameters, arguments, and return values, and then finish up with decomposition, modularity, reusability, and abstraction. So these are some of the most important concepts you will carry with you for the rest of your programming journey. So let's start with basics. What exactly is a function? A function is a named self-contained block of code that performs a specific task and can be run whenever it's needed, simply by calling its name. So in this diagram, we have an input going into a function, in this case called square of, and an output coming out the other side. That's the basic shape of almost every function you will ever write. So think of a function like a kitchen blender. You put ingredients in it, does the work, and a finished smoothie comes out of the other end. And here's the best part: you don't need to know exactly how the blades spin inside to use it. You just need to know what to put in and what you will get out. So why do we actually need functions? There are a few big reasons. First, they help us avoid repetition. Write the logic once and use it as many times as you need. Second, they help us organize code, breaking a large program into smaller, named, understandable pieces. Third, they make debugging so much easier. If something breaks, you know exactly which function to check. And fourth, they enable team collaboration. Different people can build and test different functions independently without stepping on each other's work. So imagine copy pasting the same 10 lines of code every single time you need to calculate something, and then imagine finding a bug in that logic. So now you would have to fix it in every single copy you made. So functions solve exactly this problem. Then how input and output actually work inside a function? A function can optionally take in input to work with and can optionally send back output when it's done. We define a function called square, which takes in a parameter called number. Inside it calculates number times number, stores it in a variable called result, and returns that result. When we call square with the parameter 5, the input is 5. So the output is of course 5 square 25. So in this example, number is the input the function receives and result is the output it sends back after processing. That's the fundamental input-output relationship every function follows. Then now the two terms that get confused constantly is parameters and arguments. A parameter is a placeholder variable listed in a function's definition. An argument is the actual value passed in when the function is called. We define a function called greet with name as the parameter. Notice at this point, name doesn't have an actual value yet. It's just a placeholder. Then when we actually call greet with jidin, that string jidin is the argument, the real actual value being passed in. So the easy way to remember the difference is parameters are the names listed when you define a function. Arguments are the actual values you send when you call it. And how a function actually sends the information back? Through return values. A return value is the result a function sends back to wherever it was called from using a return statement. So we define a function called add, which simply returns a plus b. When we call add with 3 and 4 and store the result in a variable called total, total now holds the value of 3 plus 4, which is 7. And not every function needs to return a value. Some functions just perform an action like printing something to the screen without sending anything back. And once a return statement actually runs, the function ends immediately and sends that value back right away. Any code after that return statement inside that function simply won't run. And let's connect this back to something we learned in an earlier video, decomposition, which is modular programming. But this time we are applying it specifically to functions. Just like breaking a problem into smaller subproblems, we can break a program into smaller functions, each handling one specific piece of the task. So in here, a program to process an order. Instead of writing one giant block of code, we break it into 4 separate functions. Get items, calc total, apply tax, and print receipt. Each one handles exactly one clear responsibility. So each function handling one clear responsibility makes the whole program far easier to read, test, and fix. If something goes wrong with the tax calculation, you know exactly where to look. That's how the function decomposition works. Building on that idea of decomposition, let's look into a bit deeper of modular programming. Modular programming is an approach where a program is divided into separate independent modules, each handling a specific part of the overall functionality. Take a look at this diagram. We have 3 modules here: login, payments, and reports. Together grouped inside this dashed boundary, they form the complete application. How this connects to what we just learned? Functions are the building blocks, and modules group related functions together. And here's the real advantage. Each module can be developed, tested, and updated mostly on its own without breaking the others. That's incredibly valuable, especially as programs get larger. And one of the biggest practical benefits functions gives us is reusability. Reusability means writing a function once and then using it as many times as needed across different parts of the program or even in different programs entirely. We define our square function just once. Then we call it 3 separate times. Square of 4 gives us 16. Square of 9 gives us 81. And square of 12 gives us 144. And we wrote the logic for square exactly once and reused it 3 times. Reusability is genuinely one of the biggest time savers in all of programming. And now a concept that functions naturally gives us, whether we realize it or not: abstraction. Abstraction means hiding the complex internal details of how something works and exposing only what the user actually needs to know to use it. Here we have a black box, which is start car. Hidden inside it are things like ignition, fuel injection, spark plugs, a lot of genuinely complex machinery. But as the person using it, none of that complexity is visible to you. When you call start car, you don't need to know how the engine ignites fuel internally. You just need to know what calling it does. And that's exactly what functions gives us naturally. We use them by name without worrying about their internal implementation at all. Then we have the last concept of this module: library functions and user-defined functions. On one side, we have library functions. These are already built into the language or a library and they are ready to use immediately. Common examples include print, sqrt, and length, and many more. On the other side, we have user-defined functions. These are written by the programmer for a specific task, and they must be written and tested first before they are ready to use. Examples might include something like calculate total or is valid email, logic that's specific to your own program. Good programmers rely on library functions whenever possible and write user-defined functions only for logic that actually specific to their own program. There is no need to reinvent something that already exists and work well. So let's quickly recap everything from this module that we have discussed. A function is a named reusable block of code that performs specific task. Parameters are placeholders, arguments are the actual values passed in, and return value sends results back to wherever the function was called from. Decomposing a program into functions and grouping them into modules keeps code organized and manageable as it grows. Reusability and abstraction are 2 of the biggest benefits functions gives us. And finally, use library functions when you can and write user-defined functions only when you must. So that's about the module 5. In the next video, we are moving into control flow and conditionals, where we will learn how programs actually make decisions. If function started to click for you in this video, drop a like, and I will see you in the next one. Thank you.